Vahed Kazemi, a PhD holder in machine learning and a technical staff member at OpenAI. Recently, an OpenAI employee made a bold statement on X, formerly Twitter, claiming that in their opinion, we have already achieved AGI, artificial general intelligence. This video explores this groundbreaking assertion and its implications for the tech world and beyond. The employee stated, "In my opinion, we have already achieved AGI, and this becomes even more evident with Model 01, referring to the latest version released this fall. They clarified that while we haven't created a system that surpasses every human in every task, we now have a model that outperforms most humans in most tasks. That's a significant milestone. Some argue that large language models, LLMs, merely follow predefined patterns or recipes. However, as the employee pointed out, no one can definitively explain what a trillion-parameter deep neural network can learn. Even if we liken LLMs to following a recipe, the scientific method itself could be considered a kind of recipe: observe, hypothesize, and verify. Great scientists excel because their intuition, shaped through countless trials and errors, enables them to form better hypotheses. Similarly, these models learn and improve through exposure to extensive examples. The employee drew a comparison, suggesting that the latest AI models function in much the same way. While they may not surpass every human in every task, they are better than most humans at most tasks, as evidenced by their performance benchmarks. This is an impressive achievement. However, the claim that AGI has already been reached is bound to spark debate. For some, it represents a landmark moment in AI development. For others, it might seem premature. Regardless, this conversation challenges us to reflect on how far we've come and where we're headed. Now, let's take a moment to look back at how this journey toward AGI began. In 2023, Sam Altman reportedly stated that AGI, artificial general intelligence, had been achieved internally at OpenAI. This declaration was significant, as it coincided with rumors circulating at the time about QAR, the model now integrated into GPT-4. Whether AGI was truly achieved remains a topic of debate. Some consider it a matter of interpretation. However, more recently, OpenAI's CEO indicated that we could expect AGI to become a reality by 2025. Remember this. In a Y Combinator interview, Sam Altman explicitly mentioned that this is what excites him the most.
What are you excited about in 2025? What's to come?
AGI?
Yeah.
Excited for that.
One of the most surprising things Sam Altman recently shared in his interview with the New York Times is that AGI, artificial general intelligence, might arrive sooner than expected, but its impact may be less significant than we anticipate.
My guess is we will hit AGI sooner than most people in the world think, and it will matter much less. And a lot of the safety concerns that we and others expressed actually don't come at the AGI moment. It's like AGI can get built, the world goes on mostly the same way, the economy moves faster, things grow faster, but then there is a long continuation from sort of what we call AGI to what we call superintelligence.
What he's essentially saying is that version 01 is remarkably impressive when it comes to reasoning. If you've looked at its benchmark results, you'll see just how extraordinary it is. The benchmarks we're seeing here are astonishing. These results are performing above the level of a human expert. On the right-hand side, you can see that in PhD-level questions, version 01 Preview 1 is operating at a level comparable to an expert human. That's a remarkable achievement. I agree with the sentiment that when AGI, artificial general intelligence, or even ASI, artificial superintelligence, becomes fully realized, most people might not have a strong reaction. Why? Because for the average person, there's not much direct use for AGI in everyday life. For instance, if a model can perform advanced mathematics or solve highly complex problems, it doesn't significantly impact most people's daily routines. This is why the societal impact might feel less pronounced initially. While there will undoubtedly be indirect effects as AGI capabilities integrate into broader technologies, the average person isn't likely to have a practical need for PhD-level science questions, competitive mathematics, or advanced coding skills. Another sign that we may be approaching AGI is the recent developments in Microsoft's partnership with OpenAI. Reportedly, OpenAI is seeking to renegotiate their contract with Microsoft, specifically to remove the clause related to AGI. For context, the original agreement included a provision stating that if OpenAI achieved AGI, Microsoft would lose access to the technology. However, OpenAI is now looking to amend this clause to attract more investments and secure the funding needed to sustain their operations. In this article, they discuss how OpenAI defines AGI as a highly autonomous system capable of outperforming humans in most economically valuable tasks. This definition is significant because OpenAI will play a key role in shaping how AGI is ultimately defined. Currently, the report indicates that OpenAI's board is still evaluating its options, and no final decision has been made at this time. However, Sam Altman remains optimistic that the company is on track to achieve AGI, artificial general intelligence, in the near future. Personally, I think they are being intentionally vague about this. By keeping the definition of AGI flexible, they can adapt it to suit their needs. For instance, if they require additional funding from Microsoft, they can present it one way. On the other hand, if funding isn't a concern, they can quickly assert whether or not AGI has been achieved. This strategic ambiguity allows them to pivot and move forward seamlessly based on their goals. Some individuals from Benchmark have recently shared their thoughts on the latest 0-1 paradigm. This paradigm is being regarded as one of the most groundbreaking developments, possibly even more significant than GPT-2. This is a powerful statement, suggesting that everything that follows will have a profound impact on technology. According to him, the key factors leading to AGI are test-time compute and the ability to integrate new information back into the model. These factors could allow current models to surpass the threshold of general intelligence.
I do believe that O1 is truly the biggest improvement in generalization power we've seen in a commercial model going all the way back to GPT-2. This idea of being able to do test time search, where they're allowing the model to not just generate one chain of thought, but multiple and search over them, do backtracking, allows these models to more sort of fully kind of navigate the situation space around the prompt that the user was given. Now, I think there's a debate of well, is it AGI? And I would claim no. I think there's one thing that's really missing from it that conceptually limits it from reaching AGI, at least by this definition, the way I just shared, which is it's still operating over the pre-training distribution that it was fundamentally trained on. And, the way they did this was they went and generated lots of synthetic change of thought over, formal domains like math and code and programming and things like that. There was likely informal pre-training as well, things maybe like goal to sub-goal breakdown that got sort of scored by humans. They used that signal as a reward signal for the pre-train. But you're still fundamentally limited by what data got put into the pre-train here. And I think in order to at least conceptually relax the constraints on your architecture sufficiently, you both need some form of test time search, like what O1 is doing, like what a lot of the top scorers on ArcPrize are doing. And you need the ability to incorporate information from test time back into your model and carry it forward, right? You need the ability to sort of make contact with reality and learn from it instead of having to learn from it sort of every single time.
We're taking a closer look at this, and it's pretty incredible. According to someone from the ARC benchmark, while we don't yet have AGI, we're definitely on the right track. This is a positive sign. Even though AGI isn't here yet, I believe the technology will still be incredibly powerful. When we look at the way it scales, it's clear that there's essentially no stopping it. You can see here that Noren Brown, who worked on reasoning at OpenAI in 0-1, talks about how there's really no limit to this level of scaling. The more compute power we add, the greater the accuracy we achieve in these benchmarks. Now, let's dive into one. This figure was shared in our research blog post. On the x-axis, you see test time compute on a logarithmic scale, and on the y-axis, we have accuracy on the AMI exam. This is a challenging math test for the US Math Olympiad team, where all the answers are integers. As we scale up the amount of test time and inference compute in 0-1, the accuracy improves significantly, going from around 20% to over 80% on this exam. And the most fascinating part is that there's no sign of this process slowing down. Of course, it can't go past 100%, but it seems that if we continue pushing it further, we could see even greater performance on this exam. So my question for you is, do you believe we've truly achieved AGI? I somewhat agree with the person at OpenAI who mentioned they've already achieved AGI. Personally, I think it's still a 50-50 situation. We're about 70% of the way there. Once we create a system that can interact in real time and learn from its mistakes, it'll be a whole new game. I believe this could happen with versions like 0.2 or even 0.3. Considering the new developments in the field, things are likely to progress faster now, especially since these companies clearly understand what's at stake.